Next in our program is Dr. Karol Czarnota from Geoscience Australia. He is the Principal Science Advisor for Minerals, Energy and Groundwater Division. Karol is the Principal Advisor at Geoscience Australia and is focused on shaping the strategic science direction. He has over 20 years of experience in undertaking and leading pre-competitive geoscience programs focused on understanding Australia's geology and its resource potential. And we are really looking forward to hearing about from Karol today about the Resourcing Australia's Prosperity program. Thank you, Karol.
Well, thank you for that introduction, Anna, and thank you for the warm welcome, and good morning, everybody. It's a real pleasure to be here to talk about the largest initiative in pre-competitive geoscience that I think this country has ever seen, the Resourcing Australia's Prosperity Initiative, and how we're working with the Geological Survey of South Australia and how we plan to work with them in the future. So, as I start, I want to join with Paul in terms of the acknowledgement of country here, and I want to pay my respect to elders past and present and any First Nations people in the audience today. I'm sure that you are all aware that the race for critical minerals is on. National security is of increasing concern around the world, critical mineral markets are concentrated, and the global energy transition is well underway. Within this context, the Australian government sees great opportunities to leverage Australia's national position as a very resource-endowed country to be and continue to be the reliable provider of resources for the world and become a renewable energy superpower. The scale of this transition is immense, and it's mostly driven by technologies for net zero. Year on year, electric vehicles are set to increase by 30%, wind power by 6%, global sustainable battery, household batteries, stationary batteries by 8%. And on top of that, we have the growth of technology, of defence and space needs. And all of these require the resources that we can provide. The forecast here of growth of about 4 times fold, but don't be under any illusion. We are already in this right now. Over the last 2 decades, the demand for these commodities has risen by about 230%. And it's within this context that the government sees that we have a great opportunity. As the Prime Minister says, we need to aim high, be bold, and build big to match the size of the opportunity in front of us. And this is where the Resourcing Australia's Prosperity Initiative comes in. In May, at the budget, the government announced a $3.4 billion investment over 35 years into pre-competitive geoscience. It puts us firmly on a foundation to plan well going forward into the future. I think it also acknowledges maybe the theme of this conference: trends come and go, but geoscience is forever. And I think this is quite amazing. As part of this, we're in the process of working out how the first 10 years of the initiative are going to be spent. We've got $566 million, and over the last few months, we have been going through extensive consultation. We started off by linking with our counterparts, such as the Geological Survey of South Australia, identifying the priorities that we think we need to invest in the pre-competitive geoscience to make a difference. We then took those priorities to industry and academia through a series of 23 different consultation sessions. We had a survey out open for about 2 or 3 months. We had 77 submissions, predominantly from industry and long submissions from peak bodies. And it's this that we're now gathering all together to shape a roadmap for this program, which we aim to release early next calendar year. So, the consultations themselves and the program are structured around 4 interconnected components, shown here on the screen. The first one, Australia-wide geoscience datasets. Well, these are the building blocks that we use to understand the geology that's on the surface and below the Earth's surface. These are some of the datasets that Paul talked about, like the wonderful magnetic coverage over the Gawler Craton here. The idea is to increase the quality and the consistency of these datasets and coverages across all of Australia to support minerals, energy and groundwater understanding. We're talking about geophysics, geochemistry, and geology in these cases. The next theme is national resource assessments. So under this theme, the idea is to take all that information and come up with an inventory of Australia's resource potential. It was actually what our predecessor organisation, the Bureau of Mineral Resources, was founded to do, and we're starting to do that, to provide these national scale examples of this, which help reveal new exploration opportunities, help with land planning, and also help companies raise investment into areas of high potential where they have projects. But we can't do everything just nationally. There is a whole lot of areas where we have great uncertainty, but where we think there is still great resource potential. In these areas, we're going to do deep dive projects. During the consultations, there was great debate in terms of, do you go into completely frontier regions, here be dragons, where you just don't know anything, and do the projects there? Or do you focus on areas which already have some idea of where the mineralisation is and look for extensions? And it seems as if we're landing somewhere on a mixture of both of these two components. And the fourth component of the program is data and knowledge. It's a recognition, really, that focusing on data delivery and our relationships with stakeholders is just as important as the geoscience that we do. If people don't know what we do, you can't use it, and it's of little use. So what I'm going to do now is I'm going to go through and provide some more specifics in terms of what we're getting back from the consultations as I go through these various themes. So we're going to start off with Australia-wide geoscience datasets. Now, when you think of this, a lot of the time we think large dataset collection, and that's certainly part of that. One of the amazing datasets that have been acquired over the last 8 years is the Airborne Electromagnetic Survey, AusAEM, flight lines spaced 20 kilometres apart, giving you conductivity sections down to 300 to 500 metres of depth, and it's useful for minerals, energy and groundwater. Granted, that is a bit of a hole at the moment in South Australia and across other areas, and it's precisely these types of gaps that we're looking to fill during this program. But during the consultations, we heard that not only do we prioritise making sure that we've got coverages like this and of gravity and of passive seismic MT and so on, there is a great desire there to improve the amount of collation and standardisation of the datasets that we already have. And what we're talking about here is datasets that are collected by industry and submitted to the states and territories, the information from the states and territories and from the federal governments, all brought together under a standardised framework. Maybe a federated model in terms of how that is delivered, so everybody's custodianship is maintained. So we're going to be focusing certainly on that component. And we're not going to stop there, we're also going to interpret. And on that particular theme, I want to show you one way of interpreting things. So inversions, geophysical processing, is in a sense an interpretation of the data that is collected ourselves. For many years we've been investing in this type of approach, especially for airborne electromagnetics, and what we've delivered to date is the section that you can see up the top here. This is what you normally see if you go in through our portal. Over the last year or so, we've been making great strides in unlocking the potential of supercomputing. The scale of the supercomputing here to come up with probabilistic interpretations of the data, that is, all of the models that fit the data that you collected within the noise of that data, you can then present 3 key bits of information. One is, what is the 10th percentile of the conductivity, or the 10th percentile of most resistive models across the region, the median, and the 90th percentile, or the most conductive series of models. When you do this, by embracing the uncertainty, you actually end up sharpening the image. It's amazing. Have a look. Here, in the top one, you cannot see these little features, these layers across the Eucla Basin. These are all sections from South Australia in the Eucla Basin at the moment. You can see that there is a whole bunch of bleeding data over here on the right-hand side. It's gone on these better sections. You've got so much more fidelity, and this is what's coming when we come and deploy these types of techniques in the future. But it also speeds up interpretations. If you've got questions such as, where am I most likely to be able to find fresh water across the region? What you can say is, well, let's look at the most conductive section and find the most resistive bits in potentially a suitable reservoir, which will be down through here. If you're exploring for, say, clay-hosted rare earth elements and you're looking for conductors, you go to the most resistive P90 section and look for the conductive regions. They're the ones that most likely have the greatest concentrations of metals within them. So as we do this, we try to speed up interpretations, and with those interpretations, we try and translate into the geology. Like the solid geology that Paul just showed across South Australia, we're trying to compile all of that across the entire country, and we're going to continue investing in that. We've got the first layered solid geology across the whole country, which was released earlier this year as part of the Exploring for the Future showcase, and we're working at the moment on a national coverage of sedimentary thicknesses, which will continue to grow as more data is compiled. But effectively, that determines the exploration search space, and these are fundamental inputs into our techno-economic models. If you've seen economic fairways, that's the sort of information that it really requires to be able to work out what the net present day value is of a potential project somewhere undercover. So we're going to continue to invest in this, work with the states and territories to make sure we've got consistent understanding of Australia's geology and how it's developed through time. Okay, national resource assessments. Under this theme, we have a commitment that we are going to assess all 31 critical minerals, all 5 strategic materials, look at the potential of geological storage for hydrogen, carbon dioxide, as well as offshore suitability for infrastructure placement. And that we're going to be doing those things nationally over the next 35 years. We are not abandoning the mineral potential approach in making these types of assessments. So, for example, here you've got 3 different systems, all of which have copper within them. These are national scale assessments, and they're combined to an indicative copper mineral potential map across the whole country. So obviously it's incomplete. There are other systems like porphyry copper, VHMS and so on, which have significant endowments of copper, but that's where we're going, and that drives innovation in terms of how we compile and how we collect suitable data sets for this type of work. In addition to this though, new frontier places for discovery of mineral deposits are not the only places where we can find new resources. So the mining estate, so looking at remining potential from mine waste is a great opportunity for us, especially for critical minerals, where about half of them occur only as co and byproducts. You know, we will not go and find a gallium mine or a germanium mine and so on. They're all associated with other things. And some of these elements deport into the tailings, mollusk heaps and so on. So what we've been doing is mapping out the distribution of these features across the country and working with Geological Survey of South Australia and other jurisdictions to sample this material and identify the opportunities that lie within them. So, as Paul said, development of resources requires water. Australia is the driest inhabited continent on Earth. Over the last few years, as part of the Exploring for the Future program, we've done a rapid inventory of Australia's 42 hydrogeological units, what we broadly know about that, and then we've zoomed in and started to compile and standardise data. The first place we actually did this was the Lake Eyre Basin. It's the first time that the geology has been compiled across the different states and territories, across that jurisdiction, and provided indicative water table maps, standardised the stratigraphy, and worked out what the hydrogeology across those areas are, and focused on water, not just potable water, but also the brackish, the slightly saline that can be used for other applications. So this is what we're going to continue to roll out as part of our work, and we've got a commitment to do all 42 hydrogeological units across the whole country over 35 years. So these are big tasks and also exceedingly exciting. All right, the deep dive projects. So this is where effectively we focus critical mass. We hope to have the largest concentration of data collection in those particular regions, and we also test and validate the national assessments in those areas through more detailed data collection. This includes things like reflection seismic profiles, drilling with MinEx CRC, or whoever comes up after them, that Paul's already talked about. We test data collection methods, and we also have an ability to pull through technology and test it, how it works in various areas. In the roadmap, we'll be identifying the next 4 deep dive areas that we'll be focusing on, in addition to 2 that have already been announced by the Minister. So one of the motivations for a long-term pre-competitive geoscience program is the recognition that when you go into a region, to get your head around the geology, collect the information in progressively higher resolution stages to narrow in and identify presence of mineral systems or lack thereof, it takes time. It takes normally about 6 to 7 years to do that. So we're going to be continuing to work in the Delamerian region. So this is where we're pulling information from New South Wales, South Australia and Victoria, bringing together the National Drilling Information Surveys. Tom's going to be talking about the deep reflection seismic profile and its interpretation through here that we've been working on together. It's amazing, you know, the Torrens Hinge Zone, Stewart shelf sediments, they go up to over 10 kilometres or so, Tom, I think, in that area. So we're providing, I suppose, first new order information around that. On the right-hand side, you can see some work by David Moll, where he's doing lutetium-hafnium dating on rocks, including the National Drilling Initiative. Some of the information is still coming in as we're continuing to work on that. But what's lovely to see is that in this region of the Delamerian, we start to see this older package out to the east. So you're really starting to see that maybe we're seeing the continuation of crustal material out from the Gawler out to the east as part of that rifting episodes. These are the types of concepts that I suppose we're thinking through and testing, and the extension of the Delamerian project will let us to consolidate all the information that we've collected over that period of time. So the last component is delivery, awareness raising and engagement. So this is a recognition that we need to partner with communities in order to have maximum success for our work, and that includes First Nations people. So one of the aims of the Exploring for the Future program is to increase the economic and environmental self-determination of First Nations people through the provision of geoscience information so that they can make informed decision making from that. We've also established collaborative partnerships here, the Lake Eyre Basin Rangers. I think, Steve, you may have been part of this trip in terms of mapping the soils across that region, and they're bringing it into their management of country, also how to sample groundwater and monitor its quality, and so on. And these are the type of work that we intend to continue as part of the Exploring for the Future, and especially within the deep dive regions. Another theme that we've heard from our consultations is that, your data delivery systems are good, but they could actually be better. The human experience could be improved quite a lot in terms of the intuitiveness, in terms of how to get the information. And that goes for both the subject matter experts who are pulling down the rawest forms of data to work with them and reinterpret them, and also the communities, the policymakers who are looking at, well, what did you actually learn about the resource potential? So the place where you can get the raw data is our portal at the moment, the data discovery portal, and we've developed a new tool called Geoscience, which provides that so what. What are the resources across various regions across Australia? What do you know about them? What do you know about the resource potential? And what are the links to other data sets in terms of things like infrastructure and the like? So we'll continue to invest in these and also to invest in the back-end parts of all this, which is the various databases, trying to synthesize in terms of getting the data sets readily digestible through large AI models, large language models and the like. So I take it that's a theme that's happening across many of the geological surveys across Australia at the moment. All right, so what difference is this going to make? So one way to look at what difference it's going to make is to say, well, what difference has it made through time? So the Resourcing Australia's Prosperity Program builds on the success of the Exploring for the Future program. So over the last 8 years, and over that time, we have been tracking how many companies have used the information that we provide to make decisions for exploration. It's a task that David Upton, somewhere in the audience over here, that helps us with that from pre-competitive review. And he effectively calls a company once you've picked up tenements and asks, have you used this information? And this is a map of over 160 companies who've picked up over 1,300 tenements spanning more than 500,000 square kilometres. That's an area double the size of Victoria. Over those last 8 years using pre-competitive geoscience from the program. And we expect this to continue. So what difference does this make? Well, This information, I think, is the reason why we've had a resurgence in terms of Australia's share of mineral exploration expenditure across the country. So we went down from rock bottom of 8%, our lowest ever share of global mineral exploration in 2015, and now we're back up to 18%. And in relation to that, we've had a growth in discoveries that matches that expenditure. The reason why I think it's making a difference, because when we asked why did companies leave in the first place, it was because, you know, the undercover search space was just too hard. But I think together as a community, we've been able to show that we can unlock this particular search space. But the key in all this is how many Tier 1 and Tier 2 deposits are we finding. So since 2017, there were 41 of these discovered around the world, according to Richard Shoddy. And looking into their discovery stories, and so 10 of these were in Australia, and looking at the discovery stories, about 7 out of the 10 used pre-competitive geoscience to go and explore in those particular regions, or to help with exploration in areas that were already present. So it was lovely of BHP Billiton, for example, to acknowledge that the mineral systems models developed by Roger Skira and others helped them in their discovery of Oak Dam, along with the many other data sets that are provided by the Geological Survey and others. If you have a look at the macro level and you zoom out, we had a Deloitte study that had a look at what is the value of pre-competitive geoscience Australia provided by ourselves and our state and territory counterparts, and it turned out that in terms of downstream value that it generates, it's about 1,000-fold. These are ridiculously large numbers, but it is comparable to the scale of the mining sector. It supports about 3.5% of Australia's GDP, and this is not including assessment of coal and iron ore. Currently, the forecasts for the net zero transition and rise of importance of battery minerals, permanent minerals to support permanent magnets, and so on, is that by 2040, that sector is going to be larger than the coal sector. So the opportunities here are big, and the future is bright. And thank you very much for listening to me today. And if you want to hear more, come along to tomorrow, where I'll provide a little bit more information of the type of work that we do. Thank you very much. And over to Anna.